Next generation recycling is the use of innovative recycling technologies that have the ability to recycle hard to recycle materials like mixed plastics and flexibles. And they enable us to do more for material recovery and end of life than existing recycling approaches, which have a limit to recycling as it downgrades the material in the process. And this form of recycling uses vision and robotics to help understand more about the materials being collected and sorted in recycling. So the benefits of next generation recycling, like for example chemical recycling, are that there is a potential to depolymerize materials, recycling them on a chemical level. And that brings them much closer to the virgin materials from which they were produced originally. And this significantly extends the product life of these materials. Taking these materials back to their chemical component parts could be said to remove the notion of waste altogether, and the materials can then be used to produce something else, like fuel. Besides the benefits, there are some risks and disadvantages about next generation recycling. I'd like to give you 3 examples of some of these risks. So first of all, some of these technologies actually require a lot of energy to make recycling possible. And there's also the issue that there's a limited infrastructure and capacity today to support this kind of recycling, especially in the global north and the global south. The second risk is around the fears that chemical recycling could actually create other forms of waste that are equally harmful to the environment. And some suggest it is more damaging to take the component parts of recycled plastics and burn them as fossil fuels when they could have been used to produce other plastics, as this is contributing to carbon emissions. However, at the end of the day, it can still be said that this is better than not recycling at all. And the third point I'd like to make is that there is an issue today around the small percentage of material and products that can actually be recycled and reused. And today's extensive mix of material types in products makes it really difficult to make recovery economically viable. So that to say, there are some advantages, but also definitely some disadvantages about next generation recycling.
Government certainly has a very large role to play in the continued advancement of chemical and new novel recycling technologies. Any conversation around government must obviously also include the regulatory environment. Globally, there's a requirement and an appetite to speed up regulatory, but that appetite varies across the globe. For example, in Europe, there are a number of differing regulations that govern the use of chemical recycling, whereas the US tends to be much more open to enacting consistent and stable regulations in this regard. Second, typically, advanced recycling technologies do require high levels of capital expenditure. This is a key area that government can play a role in by helping build and support the infrastructure necessary to accommodate those large capital expenditure programs. And then finally, there needs to be a consistent move towards what we would consider a hyper-localized ability to recycle materials within their local communities. That will require continued advancement of chemical recycling technologies and potentially lower capex, more modular-based systems, again supported by local municipalities and government. Advanced recycling technologies can unlock major opportunity in 2 key areas. First, materials that were typically considered problematic or difficult to recycle can now be processed in such a way where they are returned to an almost virgin-like state. 2 key examples in this area: polypropylene, or plastic number 5, and polyester. The second key opportunity that advanced recycling technologies enable is the ability to take typically low value materials and enhance their value for the benefit and support of local communities. Typically, PET has been the material of choice, holding the highest value in the world of recycling. Advanced chemical recycling technology allow for enhanced value on other materials, including polyester and polypropylene.
So to summarize, next generation recycling makes it possible to recycle hard to recycle materials, like mixed plastics, but also flexibles, for example, wrappers for vegetables. Technologies like chemical recycling bring materials much closer to their virgin material state, extending the product's life cycle. However, these type of technologies do require a lot of energy to make recycling possible. There are also fears of creating other forms of waste, and last but not least, today only a small percentage gets actually recycled and reused, making it difficult to make this recovery economical. If we can tackle these challenges, however, next generation recycling could be a really interesting solution to tackle our global waste challenges.